Welcome, everybody. We're going to be talking about Unit 3 today, which covers Chapter 4 in our book. And that's from the Murach's MySQL third edition, by the way, if you're keeping score. The general topics that we're focusing on are kind of a combination of things. The primary ones are inner joins, outer joins, and on a really light level, we'll talk about unions. But there's also understanding the difference between a left outer join and a right outer join and what all that terminology means. There's also this concept of aliasing, which we've already kind of been doing a little bit, but we're going to take that up to another level tonight because it's necessary when you're joining tables so you know what table you're dealing with, basically. As I mentioned before, the W3 schools site, and that's all linked up from those topics, by the way. These all, and you know what? I think I might add a couple more links here, but I'm going to do it after the fact. But W3 Schools has an excellent collection of reference materials. I think their examples are clear. The unfortunate thing is there are ads on the website, so I always try to like not highlight those. But I think they do a nice job of explaining the materials very, very succinctly. So I'm going to be predominantly using some of this stuff for lecturing over the PowerPoints, although I will bring the PowerPoints in as well. You can see them up here, all poised, ready to go, just to kind of highlight what's important, I think, in the chapter readings. All right, the whole concept of an alias, and we have already played with this a little bit last week, is that when you're dealing with a table and then the table has a column name or whatever, sometimes the column name is set up so that it works in the database structure and doesn't necessarily make it readable or look pretty, right? But then when you run a query and you get the output, it'll come up on the little output window with that cryptic name, and sure, the database person knows what that is. But if you're taking that output and presenting it to somebody else, maybe not, right? Sometimes the alias is just simply a way of changing the name of something so that you can basically make it look nicer than it did before. So, for example, if I have a database column that's called customer ID, that's not super friendly. And you know what? If you're talking to the customer, it's like, what's their ID? So in other words, I'm creating an alias for customer ID, which is a column in the table, and I'm just calling it ID. Why? Because it's easier, and also because this actually might be longer than the ID. So then it creates this like wider column than it needs to be, where ID numbers might be only 3 or 4 or 6 characters long, and that just looks nicer. Same thing here, customer name, and then just change it to customer, right? So I'm not going to run this code or anything. I'm just showing you an example of what an alias is. Aliases can be used in a number of other different ways, right? So if you wanted to make something really look nice, right, you can actually put in double quotes, actually insert spaces in there. We played a little bit with this last week too, if you remember. And this is really kind of on the eye of the person running the query or creating the code to do this. More examples, and the ones that we're going to kind of start touching upon today. If I'm working with one table, right, the aliases are going to be mostly about the columns. Like I don't like the way the column is named, so I'm going to make my output look nicer. But when I'm starting to work with multiple tables that are related together, where they have pieces of information that are shared. So, for example, if I'm looking at my customers table and there's a customer ID, and then I'm looking at my orders table and there's a customer ID, so I know which customer bought it, and the same information is in both tables, well, I can join those two tables, but how am I joining them? I'm joining them on that customer ID. So how do I know which ID field I'm even referring to? And by the way, do I need, like, if I'm joining them on that field, do I need to display the field from both tables? So these are all the kind of weird questions you start to ask. And then more importantly, how do I identify, for example, which table that information is coming from, or which column or what table does that column come from? If you feel where I'm going with that. So what is very conventional in writing SQL code for database people is if they're joining multiple tables together for a query, that they take, let's say, the customers table and they convert it to like a 1 or 2 letter like micro alias, so that when they put C in front of customer name, I know it's from the customers table. But I'm not saying that. I'm just saying C, right? And then here, we're looking at the customer ID from the customers table, but we're looking at the orders table and the customer ID there. And notice in this case, we haven't learned what this does yet, but basically we're saying that the customer ID in this table is the same as the customer ID in this table. So if you're talking about 123 here, it's the same 123 over there. That's kind of the concept. The aliasing allows us to very clearly see what table it's coming from quickly without needing to necessarily spell out the whole table name, right? And that is a coding convenience, right? And so they show an example here, and actually this is a nice example where what would the code look like if I didn't have the aliases in there, right? Here, where I apply the aliases can be used all the way through the whole statement. Look how much shorter it is in this. It's a lot shorter, a lot easier to look at, right? And really the parts you're usually focusing on are the column names, not so much the table. So the convention has been in database programming, use that lowercase letter, and you know what, if you have 2 tables that start with the letter C, well, then maybe use the first 2 letters, or whatever makes sense to you, but an abbreviation as an alias. And all right, aliases, by the way, can also be assigned to databases as well. So, we're making this assumption that whenever we're working in a database, we're just working with that one database and the tables that are in that database. It is possible to run queries across several databases at the same time if they're all running on the same server. You just connect to the other database, and then you add another level of alias to it, by the way. All right. The general concept of joining tables is really kind of built around this concept that when you are putting stuff into a database, you might have tables that contain singular types of information. So, for example, if I had a customer table, what kind of information should go into that customer table? Well, think about it. I would probably have their name. If I had access to it, their address, city, state, zip, probably their phone number, maybe their email address, and maybe another couple pieces of information that are key that make them a unique entity as a customer. Right? Chances are the customer would have an ID number of some sort or an ID field. And then in other parts of the database where I maybe have like orders, and I think that's a great example, that customer is buying things, and every time they buy something, there's a order record that would be created that would be attributed to them as a customer because of their ID number. I wouldn't need in my order table to replicate all the information from the customer table in the order table. Like, not necessary, right? So think about that. Like if you go back to the same website all the time and place an order, they don't need to put your demographic information in the order table. That's already in the customer table once. That's enough, right? But in the order table, all they need is your order ID, or excuse me, your customer ID, and then what you're ordering, right? And then you can take it out farther than that. But the value of joining tables ultimately is now I can pull information from both tables. So if I want to like do an invoice, for example, relative to that order, I can take your personal info from the customer table and put it on the invoice. And then you have the address too, and all the products that you ordered and all the other information. right? So that's kind of the power of it, right? So they're taking a look here at a sample database, and let's just kind of look at their example. It says, let's take a look at the selection from the orders table, right? So you have an order ID, a customer ID, and an order date. Okay, so here comes the thing. Where's the order information? Well, that's the order ID. That's in a different table, right? And that might be called invoices. In the customer table, I have customer ID, the name, contact name, country, whatever demographic information you have. And then if I do what we call a join, and this is a real basic join, by the way, I'll try to leave both things on the screen at the same time. Basically, once again, we're looking at pulling information from the order table, the order ID from that table, the customer table, the customer name, the order date from the orders table, and then we're going to join that, and this is called the inner join, with the customers table. What's the joining piece of information? We're joining on the customer ID being the same in both tables. And then when you run that, what will happen is you will basically get the order ID, customer name, and order date, because that's the stuff we're selecting from the results. But we're going to play with this a little bit so you can see that if I'm joining and I'm not specifying the stuff that I highlighted here, like you just did a star, for example, you would see that it would take, both customer IDs and display it because you're joining it, right? It's going to this customer ID and this customer ID and all the information that's possible, it'll throw it in there. So the join is a way to really access both tables at the same time. Now, there are some considerations, right? So the one consideration is, what's the joining piece of information? And more importantly, is that piece of information unique? Is it a one-to-one or one-to-many or many-to-many kind of relationship? So you very intuitively would say, well, there's only one of those customers, right? So that's a unique customer. However, that customer might make many orders, right? So you can see that customer might appear in the order table many times, but only appears in the customer table once. And just because we have an order in the order table doesn't necessarily mean that there's a customer attached to it in the customer table. We would hope so, but how do we guarantee that? Well, this is where we start to learn about keys and indexing with primary keys and foreign keys, and that stuff is coming up, by the way. That becomes important. Here's kind of another little diagram, and students hate these kind of things, like I would assume, right? Because I hated them when I was a student. But we look at the conceptual thing of what's happening. The first kind of join that we're going to learn is what we call an inner join, meaning what is the piece of information that the two tables have in common? So for example, in the example above, it was the customer ID, right? Then there's a different kind of join called a left outer join. By the way, that's the formal name for it, but a left join. And okay, so that means we're taking everything on the table on the left and including it, and only the part that overlaps from the other table. All right, so depending on what kind of information we want to look at, that's really what drives this. Do I want to see all the orders from that one customer? That would make sense. If this was the customer table, I just need their customer info or ID. And then this is all the orders. Right? That's kind of the concept. The other thing that sometimes confuses people is like, well, which one is the left and which one is the right? Well, whichever one you state first is the left. That's how it works, right? There's no rule, right? And so if that scenario doesn't work for your answer, if you wanted it the other way around, let's say this is the customer table and this is the orders, then you really want to right outer join, because why? Because you mentioned the customer table first. That's the why. So that's how you are forming either a left inner join or a right outer join. One table's entirety, the other table's overlap only. Then there is the cross join, where we're completely merging both tables. And you know what, there are scenarios where that's really a thing. Um, and then that goes down a rabbit hole of like self-join and union, which a little beyond the scope of what we're doing here tonight, especially in terms of the homework. Um, but this is kind of very helpful, I think, in terms of understanding the basic way of how it works. You know, it's a quick little graphic, and it really, to me, says a lot.
I
I'm
have
going
a
to move on. Yes, George.
I if I heard correctly, you misspoke
Okay,
on the left join. The left and the right join are both outer joins. Is that correct?
correct.
Yeah, I think you called the left join an inner join by
Okay, well,
mistake.
if I said that, I apologize.
Okay. Yeah. Thank you.
Thank you for clarifying. Well, thank you for catching that. And, you know, guess where we're going next, right? Um, and yeah, those are both, yeah, correct. And here's the correction for it, George. So thank you for identifying that. So the first one you tend to learn is this inner join, and this is where we find basically the overlap between the tables. Um, so from a conceptual standpoint, you got the two tables, a piece of information or pieces of information that overlap are in that inner join. And notice here in the generalized SQL syntax statement that we use that keyword inner, you know, so inner join is present. Now, let's take a really quick look at their um, example here. So here's a little bit from their orders table. And you can see order ID, customer employee ID, order date, and shipper ID. And then we have a little snippet from their customers table. You can see the basic like demographic kind of stuff. So ID, name, address, city, postal, etc. Right. And then where is the overlap? Okay, so where is the overlap? Let's just ask that question. That's a pretty simple one. Right. And this will mimic our homework, by the way. Well, the easy answer is it's the customer ID. So if I'm looking at this particular order ID and I see the customer ID is two, we're that's the common piece of information here. So when we form this inner join, we'll look at the syntax, right? So we say we take the order ID field from the orders table. That's going to be in our output. The customer name from the customers table, right? Those are the pieces of information that are going to show in the result. We're querying the orders table, and then we're doing an inner join, so meaning only the overlap on the customers table. What are we joining on? Well, on the orders customer ID field and the customer's customer ID field. And I know these are hard to verbalize, right? It's like you trip your words over it, but conceptually it makes sense. How do you know where the overlaps exist? Okay, so here's another crazy question. Well, if you had a database diagram and you could look at it, you could just visually look. Otherwise, you are going to be going into the table structures and looking at the columns and going, what's the same? Oh, these are the same. And then you'll also, and once again, once we learn about primary keys and foreign keys, we'll have those little pieces that show us the connections as well, because those enforce the relationships, right? Now, if we wanted to join more than two tables, right? What if we had three tables? And this kind of stuff is actually not uncommon. So the example that they're ramping up now is basically they're pulling stuff from the orders table. So they want to see the order ID from the orders table, the customer's name from the customer table, and the shipper name from the shipper's table. And we're querying starting with orders on the left, right? That would be the left portion. And then that's interjoining on customers with the IDs. We already did that part. And I want you to notice the parentheses here, because this is one complete statement I just highlighted. And notice how there's a second set of parentheses here, because now we're adding another layer to it. So really what we're doing is we have this thing that's already joined, these two circles that are already joined, and now we're taking those circles and joining them with this shippers table. And what are we joining on? Well, the orders table shipper ID and the shippers table shipper ID, the pieces of information that are common. Notice these pieces of information are not part of the customer ID or the customer table at all. But because the customer table is linked to the orders table now, we can take the shipper table, which also lists the order table, and connect it to the customer table and get a more complete view of the information. And I don't know if they show an example of the output there, but so in other words, you can actually take these statements, and if you can conceptualize it, you can have it go even more layers deep. So you can go like four tables or 5 tables, as long as you can get the syntax correct and you can conceptualize it correctly. It's not uncommon to do this. And think about that. If I was able to say, hey, what did Joe order? I could look Joe up. I could see his orders, and I could see how it was shipped. Makes complete sense when you think about it in a practical way. In the database, it does not make sense to put, all of that information in one table. The database will operate better if it's all separated. Everybody okay so far? All right. All right, let's move over to the left join. And I'm also keeping my eye on the clock here, just so you guys know. We will take a break about halfway through. So let's take a look at the left join scenario, right? And it says it returns all the records from the left table, table 1, and the matching records, if any, and that's in parentheses, from the right table, right? So this is not assuming that there actually is that information in the right table. So it is possible to get null responses in these situations. So just be aware of that. Right, there's the generalized syntax. Let's take a look at their little demo here again. So they have another customer table, same info, I think, as the previous screen that we looked at. And then we have the order table, and we can kind of see them both here at the same time. What are the common pieces of information here, folks? Well, it's the customer ID. So if I'm going to take everything from the customer table, that means all of this information would appear, and I only take the shared information from the orders table, what will that output look like? Well, provided that the customer has placed an order, right? So here's the other piece. It would show all their demographic information and all the order information. No, not all the order information, just the order ID, right? That's the overlap part. And actually it would just show the customer ID, right? Wait, would show all of this, think about this, and only the overlap, and then it would show that. All right. So here's an example of the verbiage that we would use. This is not aliased, by the way. They're using the long names on the tables, but we're going to have an output of just the customer names and the order ID, because maybe that's the information they want. They start with the customer table on the left join orders on that same piece of information, and then order it by customer's name. All right. Now, we can go ahead and just run this SQL really quick, just so you can see what the output is. And the reason that we're only getting these 2 columns of information, by the way, is because that's all we're asking for. But I think to show the full left join, let's do this instead. And notice the contention I made before is correct. I have all the information, right? And then if you keep scrolling, and of course I'm like zoomed way out, notice what's happening is it's basically including all the information from the other table as well, You see how weird that is, right? Because now we're selecting everything that's possible rather than just the pieces we need. We will tinker with this when we actually get to running code, by the way. But I think it's kind of neat when you get to play with it here in the environment. All right, let's talk about the right join really quick. Very similar. We just basically change the syntax, and really it's the one on the right where we want all the info and only a select piece of information from the one on the left. It's that being selective that really kind of identifies this. Once again, orders table, right? So we're going to assume that's the table on the left, and then the employees table, right? All right, so let's follow through here. So they're going to be pulling the order ID, last name, first name from the orders table, right join on employees, but then we're also pulling in the employee ID from both of those tables, and then we're ordering it. All right, let's give this a run and see what it does. So notice the simplicity here. We're just getting the order ID, last and first name. This is the last and first name of who? The customer? No, this is the employee, right? Has nothing to do with the customers in this case. Once again, you want to see what this is kind of doing if we select all the columns that are available. And I think that's kind of a fun little experiment to do. You can see that it's trying to pull in everything from both of those tables. And I think if I zoom out, you'll see all of it, including the notes. And notice we're also pulling in, the employee's picture file and everything. Let's keep moving on, folks. I'm not going to go super deep into these other ones, but I am going to talk about them briefly. There is what we call the cross join. And yeah, and I like this little warning that they put in here because that's very pertinent, right? And often why we avoid doing it, in the database world, especially with large databases, it can potentially return super, super large data sets. Okay, maybe that's not generally a problem, depending on how much data you're querying. But what if you had like two tables with like 100,000 records each, and each with 20 columns, and now you're joining them? Yeah, that can create a whole lot of data. And by the way, like even just thinking about these scenarios, right, makes your brain hurt a little bit, because this is the kind of thing that challenges us that are in the data field, right? Is we do have vast amounts of information that are available to us often, and then how do you use that information wisely to extract the information that you need to accomplish whatever knowledge you want to gain or task you need to complete, right? It's often not by pulling all of it in, it's by pulling in the pieces that are important, right? So that's why I kind of am hammering that a little bit. Now, if we once again take a look at a customers table and an orders table, we've been looking at these, right? They can still select individual fields from those tables, right? And make it efficient, right? So in other words, if you run the SQL on it, right, you're just getting those two pieces of information. The moment I start striking that and then looking at the whole possibility, well, then the data set is going to basically expand in size significantly. I'm not sure if I'm making this crash right now, but it doesn't seem to be. Okay, there. Okay, it took a little bit, right? So still 75,000 records, but now that's like scaled out so far. And I think I'm making my computer like choke on this, by the way. I don't know if it's like running in the browser or something, but the browser is choking on it because it's 75,000 records and I'm asking it to show everything. So already, there, see how long that took, right? And I have a pretty fast machine. So this is running, and there we go. So if you picked up on what just happened there, I got the browser tab to crash. by pushing it too hard. Right. I'm exceeding the bounds of their tutorial environment, you know. So it probably has like a memory limitation and it didn't like it. Right. So yeah, precisely, Chris. Um, so this is part of the problem with working with super large data sets. And I mean, even knowing how to work with really large data sets practically is become a thing. So another thing that you can do is you can also add, by the way, I mean, aside from just joining stuff, you can start to put in criteria, right? And so we have talked about that as well. There is also um, the self join, and so this is kind of a weird one. I don't think the book talks about this that much, but this is basically we're joining the table with itself using two different aliases. And I will tell you that I find this useful only in certain types of scenario, but generally I'm going to call it marginally useful, at least at introductory levels. But they show it. And so they're doing a double alias here. So they're calling the same table by two different aliases and then using both of them. And the reason they're doing that basically is to allow them to differentiate between the information as it's coming in so they can do a comparison um, of information, right? So they're in this case, they're trying to match people up from a certain city. And what does this symbol mean? Do you guys remember what that symbol means? That symbol means not equal to. That's a kind of an old school way to say not equal. So just in case. What's the more modern way of doing that? You go exclamation equals is the more modern way. That works too. But the old school SQL way to do it is this way. All right. The other one that we're going to look at here is union. And we're going to do this one really quickly as well, because we're not really going to make it part of the homework, at least not at this point. And notice that, the slight difference in kind of what this one means. It says the union operator is used to combine the result set of two or more select statements. So in other words, I can run two different queries, one on one table, one on another table, and then I can combine those two queries together. Well, that's kind of a novel thought too, right? So in other words, we're looking at taking two separate queries, combining the info, and there's also this variant here where the union of all, right? And the difference with that one is it only selects distinct values. So in other words, if the same piece of information exists in both result sets, one is omitted. George?
I'm sorry, you're good. My wife walked by and waved at me.
Oh, yeah. Did this happen last week? Right at
Yeah, I think
6:30?
so. Yeah. I'm in a
So,
bedroom and I'm by the bathroom. So people go to the bathroom and wave at me. And I'm not smart enough to not wave back, or at least wave outside the camera area.
well, thank you. All right, folks. So let's go ahead and I'm going to call this, the lecture for now. So we're going to take a 5-minute break, and then we're going to come back and we're going to look at the PowerPoint slides quickly from the author and do a little bit of comparison as to what the stuff means. Now, when you look at the PowerPoint slides and the book materials, I think now they'll make a little bit more sense. And that's kind of my point for doing it this way. It is currently 6:31. Let's call it 6:32 and come back at 6:37. All right, now we're going to take all those materials we were just looking at on W3 and start looking at them relative to the PowerPoint from the author and how the materials tie together. So once again, you can see where this material comes from right there at the bottom. There's also kind of the listing of objectives, both in knowledge and how you apply it. And then, kind of the overall topic really for this chapter, it's from the name of the chapter, is how do you retrieve information from multiple tables or basically two or more tables is really kind of the general thinking here. They have examples here of the generalized forms of an inner join, and that's where they start the chapter, and they have some examples, and I'm not going to like detail the examples. But they're also kind of starting to look at aliasing here as well, right? And the aliasing really becomes kind of a tool, by the way. This is a good example here where they're doing some aliasing. Oops, I did not mean to move that. I was hoping to get into the text there where they're aliasing two tables. So we're going to practice that. And that's a really super common technique. And that's why I feel compelled to focus on that one a bit. So whenever you're looking at somebody else's query design, if you get into that situation, you understand what the heck they're doing. Here they're doing an example where they're only in uh, aliasing one table, right? And that's possible. And they're using a verbose name for the alias as opposed to what we saw before, right? And this is really kind of one of those examples of like, how far do you take your aliasing? Well, it depends on how ugly your table names are, basically. You know? That's really kind of a good thing. The other thing that I would point out here, and I mentioned this a little bit earlier, is that you can also use aliasing on databases. George, you have a question, please ask. Are you waving hi again?
No, I'm sorry. I must be. I don't know what I'm doing. I'm sorry.
No, it's okay. I thought it was a question. I'm just trying to jump all over it. So, right now, aliasing can also extend to the database, and I think level. So I think this is kind of interesting because there are times when we're extracting information from different databases. Maybe one piece of information sits in one database, another piece of information sits in another, and then you can use an alias to represent the database name itself, and that's what this slide is about. And they kind of talk about that for a little bit to show the examples. But if you know that piece, that can be very helpful. Next thing they talk about here is when you're joining a table. None of our homework does this, by the way. And you're joining it based on more than one piece of information. So in this example, they're connecting first names together, right? And last name. So they don't want you to join on the first name. They want you to join on the first and last name. Makes a lot of sense, right? And maybe that could also include an ID. So they make sure that all that information is consistent. More examples of that. So here they have ones that are in common, and then notice the not on this one where it's not in common, so you can kind of ramp it up a little bit. Once again, my plan here is to go through this pretty quickly. Here's some sample code for joining 4 different tables together. Sounds crazy, but you know what? That's totally normal in the database world to be pulling data from that many tables if that's where the data that you need exists. And once again, logic drives that more than anything. They keep ramping up the examples here, and yes, I am rifling through them pretty quickly. And I'm trying to get to the next important section here, which gets to the left, left join, right? And we looked at the syntax just a little while ago. And once again, we're looking at all the data from one table and not all the data from another. So you look at like one thing that happens, right, is in this example screenshot that you start getting to information that might not exist in the other table. You're pulling everything from where the vendor name is, but that vendor might not necessarily have an invoice attached to him. So that's a possibility. Then they keep going with those examples. And then they show the join here where they're pulling in the information and selecting certain columns. And then we switch over to the right join, right? And then the right join, we kind of are going the other direction. I think they do a nice job, at least in this graphic, of showing, at least conceptually, that you might have pieces of information that are missing from the left now, right? And that's why you have nulls here, because this is coming from the left table and there's just no info there. But in the right table, all all the info is there. So
I actually do have a question now.
yes, George,
Before we
please.
leave. In the select area, say department name up on top. How do you know what table that comes from?
Yeah, that's a good question. What the assumption is it comes from the departments table because that's the first one declared.
Ah, okay.
Right.
Thanks.
The fact that they didn't use the alias, I don't know why, but they didn't. But that's the assumed uh, place that it comes from. Not assumed, that is where it comes from. But excellent question. All right. Um, Here they have an example with three tables using left outer joins. That gets a little bit more complicated, and you guys should be thankful I'm not giving you homework like that, because that is actually pretty advanced. Um, but we also have the join concept, right? And I think this is a better view of it. And this is where we're basically uh, doing a join, and what are we joining on, and then we're declaring, for example, the department number in this circumstance. We're still doing a left join also, right? And that is just kind of using this different using syntax, basically, I think is really kind of the predominant difference. They talk real briefly about the natural keyword. And this one kind of gets into like a deeper conceptual space, frankly. And the concept is really to kind of make things kind of work as you would, more like you would think that they would work as opposed to how they actually work. And I really don't want to spend a lot of time on this because I'm not making you code it, so I am glossing over it real quickly. We talked also in the other examples about cross joins and how those work. And a cross join is where we're pulling stuff from both tables basically completely and having it all at our disposal. And here, it does really make a difference which table you're pulling the information from ultimately. I think there's one other little section here that we're gonna focus on, and that's talking about unions, and that's where we have two completely distinct select statements that's pulling from one table. We're combining it with a completely distinct statement from another table. And I'll tell you guys what about this is about as far as I want to take this one. This one can also be quite useful depending on the kind of information you're conglomerating. But once again, we do not have anything in our homework relative to this, so I don't want to really go too far down that rabbit hole. But just know that it's there. When you do more complex stuff, union is something that you do often use, though. All right, this is going to end the lecture stuff, so I'm going to stop this recording here.